Using all the discernment that you can muster, listen to the first couple of minutes of this video and see how it feels to you. Oh, and excuse the sound. It's recorded really rather quiet on this video, but you can see the title there. So if you want to go check it out yourself, feel free.
So you want to find the farthest point from that center. And it turns out sea level at the equator is farther away from the center of the Earth than sea level near the poles. It has nothing to do with global warming and melting of the ice caps. Why is that? Because Earth, we know it spins once a day. Three people know that one a day last year.
Good for row number 2. They're off to a great start.
So you spin, when you spin pizza dough, it kind of flattens out. It gets wider in the middle. So Earth, throughout its life, even when it formed, it was spinning. And it got a little wider at the equator than it does at the poles. So it's not actually a sphere. It's oblate. And officially it's an oblate spheroid. That's what we call it. But not only that, it's slightly wider below the equator than above.
A little chubbier.
A little chubbier. Yeah, chubby's a good way. It's like pear-shaped. So it turns out the pear-shapedness is bigger than the height of Mount Everest above sea level.
So, how did that feel to you? A particular video was published in 2014. This particular article was published in 2007 in America, in Scientific American. Strange but true, Earth is not round. It may seem round when viewed from space, but our planet is actually a bumpy spheroid. Now, before I read you some of this, I just want you to imagine that we are the writers for Red Dwarf, the sci-fi comedy. Isaac Newton first proposed that Earth was not perfectly round. Instead, he suggested it was an oblate spheroid, a sphere that is squashed at its poles and swollen at the equator. He was correct, and, because of this bulge, the distance from Earth's centre to sea level is roughly 21 kilometers, 13 miles, greater at the equator than at the poles. Instead of Earth being like a spinning top made of steel, explains geologist Vic Baker at the University of Arizona in Tucson, it has, quote, a bit of plasticity that allows the shape to deform very slightly. The effect would be similar to spinning a bit of silly putty, though Earth's plasticity is much, much less than that of the silicone plastic clay so familiar to children, unquote. Our globe, however, is not even a perfect oblate spheroid, because mass is distributed unevenly within the planet. The greater a concentration of mass is, the stronger its gravitational pull, quote, creating bumps around the globe, said geologist Joe Mert at the University of Florida in Gainesville. Earth's shape also changes over time due to a menagerie of other dynamic factors. Mass shifts around inside the planet, altering those gravitational anomalies. Mountains and valleys emerge and disappear due to plate tectonics. Occasionally meteors crater the surface, and the gravitational pull of the moon and sun not only cause ocean and atmospheric tides, but earth tides as well. In addition, the changing weight of the oceans and atmosphere can cause deformations of the crust, quote, on the order of a centimetre or so, unquote, note geophysicist Richard Gross at the Jet Propulsion Laboratory in Pasadena, California. Quote, there's also post-glacial rebound, with the crust and mantle that were depressed by the huge ice sheets that sat on the surface during the last ice age, now rebounding upward on the order of a centimetre a year, unquote. Moreover, to even out Earth's imbalanced distribution of mass and stabilize its spin, quote, the entire surface of the Earth will rotate and try to redistribute mass along the equator, a process called true polar wander, unquote, Mert says. To keep track of Earth's shape, scientists now position thousands of global position and system receivers on the ground that can detect changes in their elevation of a few millimeters, Gross says. All this technology, and they can't even take a picture of the Earth that shows that it's a oblique spheroid or a pear. Another method, dubbed satellite laser ranging, fires visible wavelength lasers from a few dozen ground stations at satellites, Rimmer said. Any changes detected in their orbits correspond to gravitational anomalies and thus mass distributions inside the planet. Still, another technique, very long baseline interferometry, has radio telescopes on the ground listen to extragalactic radio waves. Come on. To detect changes in the positions of the ground stations. It may not take much technology to understand that Earth is not perfectly round, but it takes quite a bit of effort and equipment to determine its true shape. Really? Not just a photograph from one of these thousands of so-called satellites or missions into outer space. They couldn't just turn their camera. Oh no, wait, they did, didn't they? In 2015, NASA gave us their oblique spheroid. There she be. Gorgeous NASA photo captures Earth from 1 million miles away. By Mike Wall, Space.com senior writer, July the 20th, 2015. As an aside, by the way, I've done a little bit of digging. This Discover satellite that they rave so highly about, turns out it has a 4 MB, 4 MB digital camera. My present smartphone has 16. Oh, that's nice. There was a tweet from President Barack Obama. He said, just got this new blue marble photo from at NASA, a beautiful reminder that we need to protect the only planet we have. I'll leave it there.